Good morning, everyone. And before we start, can you raise your hand if you can clearly hear my voice? Okay. And also, there is another message that Ms. Neelangi wanted to pass to you all. So she wanted me to tell you all to fill that survey that has been uploaded on the LMS. So you will find that there was a notice on the LMS under financial derivatives about the survey, and the link to the survey was also uploaded to the LMS. So please do make sure that you fill that survey, because so far only few students have filled it. So please pass the message to your friends as well, because the decisions that will be taken will depend on your response, right? So make sure you give your feedback, you fill the survey. Okay, so let's start with today's tutorial. This tutorial 5 is developed using questions. So it has been developed by taking questions from the binomial option pricing model and the Black-Scholes option pricing model. So if you talk about this binomial option pricing model, so if you look at the first question here. So in this first question, you can read it, and here they talk about two approaches here. One is no arbitrage argument and the risk neutral valuation. So you must have learned that under binomial option pricing model, there are two approaches that you can use. Right? There are two approaches. One is this no arbitrage argument, and the other one is risk neutral valuation. So if you take this no arbitrage argument, what we do under no arbitrage argument is we create a riskless portfolio, right? We create a riskless portfolio where we are certain about the value of the portfolio at maturity. We know for sure what would be the value. So that means the value of the portfolio will not be impacted by the changes in the stock price. So we create, under here, we create a riskless portfolio where the value of the portfolio is independent of the stock price. So in there, when we create a riskless portfolio, under no arbitrage argument, what it says is, if there are no arbitrage opportunities, then what should be the return of this portfolio? If there are no arbitrage opportunities for a risk-free portfolio, for a riskless portfolio, if there's no risk for a if there's no risk, what should be the return then? If there are no arbitrage opportunities for a risk-free portfolio, what should be the return that you should earn? Anyone in the chat? If the portfolio is riskless, if it is risk-free, then what should be the return on that particular asset? If there are no other arbitrage opportunities. If the portfolio is riskless, if there is no risk, we say that the return that you can expect is what? The risk-free rate of return, right? So if there is no risk for the portfolio, and if there are no arbitrage opportunities, your return should be equal to the risk-free rate of return. If there were arbitrage opportunities, what could happen? You could have earned a return that is more than the risk-free rate of return, more than what you should have got, right? If there were arbitrage opportunities. So what under no arbitrage argument is where we create a riskless portfolio and we say that the return that we can expect on this portfolio would be the risk-free rate of return when there are no arbitrage opportunities. And using that argument, we find out what should be the price of the option today. Based on this, we find out what should be the price of the option today. And then the other one is risk neutral valuation. What we do is, so if you take the risk neutral valuation, so here we are assuming a risk neutral world where the investors do not care about risk. They're indifferent towards risk. So when they are indifferent towards risk, so they would not expect any additional compensation. They would not expect any additional return for bearing risk because they are indifferent. They do not care. So here we say, since they do not expect any additional compensation for bearing the risk, even in a risk neutral world, all the assets, all securities will earn a return which is equal to the risk-free rate of return, right? Because they are indifferent, they would not expect any additional amount for bearing risk. So because of that, over here under risk neutral, in a risk neutral world, all securities in a risk neutral world will earn a return which is equal to the risk-free rate of return. So here what we do is we calculate what is the expected payoff. So we calculate, so we find out what is the probability of an upward movement and the probability of downward movement. And then based on that, we calculate the expected payoff of the option, and that based on the expected payoff of the option, we find out the value of the option today by taking the present value of expected payoff of the option at maturity. So based on that, we find out what is the value of the option today. So when we are finding this present value of this expected payoff, we use the risk-free rate of return. Because why? In a risk neutral world, all the securities will earn the risk-free rate of return. So when you are calculating the present value of this expected payoff, you should use the risk-free rate of interest, right? So this approach is what we have been using most in our binomial valuation options. Mostly frequently we have been using this, where we looked at, okay, what is the probability of the upward movement, what is the probability of the downward movement. If that is the case, what is our expected payoff of the option, and then we calculated back and found out what is the value of the option today based on the present value of this expected payoff of the option. So can you attempt this question number 1 that is given to you? Read the question. So it says a stock price is currently 40. So today the value of the stock price is 40, and it is known that at the end of 1 month it will be either 42 or 38. So this we can draw a binomial tree first, where it will reflect the different parts that the stock price can take. So today it is 40. The stock price is 40 today. And this can either go up to 42 or it can go down to 38. And it says the risk-free interest rate is 8% per annum with continuous compounding. So here we will be using continuous compounding, and the risk-free rate is 8% per annum. And what is the value of 1 month? And here this is the price after 1 month, right? And they're asking what is the value of a 1 month European call option with a strike price of 39, where the strike price OK is 39. So they ask you to verify that no arbitrage arguments and the risk neutral valuation give the same answers. So first let's do it using the no arbitrage argument. So if you follow the no arbitrage argument, what would be the value of the option that you would get? So first tell me at here, at SU, right? SU is after the increase in stock price, and this 38 will be, if you define it, it will be SD. So at SU, what would be the value of the option at SU? So we are considering a European call option. So European call option, the payoff is what? The payoff is the maximum of S minus K or 0, right? So if that is the case, what is the value? So it would be, so here now the stock price is greater than the strike price. The stock price is 42 and the strike price is 39. So will you exercise the option? Will you exercise the option? Yes. Because why? If you exercise the option, you can buy it at a lower price. So here you can take 42 minus 39, which will give you 3. So here the value of the option is 3. So at SD, what is the value of the option? If it is SD, what would be the value of the option? It would be 0. Because why? Over here, the strike price is greater than the stock price. So the option will expire worthless, and the worst it can be is 0. The payoff would be 0. So these would be the payoffs at maturity. But now we are following this no arbitrage arguments. So we said under no arbitrage argument, what we do is we create a riskless portfolio. So here assume that here when you are developing this, assume that you take a long position in a certain number of shares and you take a short position in one call option. You take a short position in the option and the long position in shares. So here the long position in shares, so we do not know what is the number of shares in which that we would take a long position. We create a portfolio by taking a long position in shares and a short position in one call option, right? So this would be how we create our portfolio. So in this portfolio, now this will be the portfolio that you will consider. Long position in some number of shares and a short position in one call option. So if the portfolio, so tell me if the price goes up, what would be the value of the portfolio? Your portfolio, you have a long position in this delta number of shares and you have a short position in one call option. What is the value of the option in this case if it goes up? So you have delta number of shares, right, with you. So that delta number of shares, the number of shares you possess multiplied by 42 will give you the value of the shares that you have with you, right? The value of the shares that you have with you. The number of shares multiplied by the price if the price goes up. And also over here you have taken a short position in a call option. So this payoff, you have a short position. Since you have a short position, this 3 would be what? This 3 will be the payoff to the option holder, right? 3 is the payoff to the option holder. From the short position's perspective, this would be what? We say it is, from the short position perspective, it has to be minus the maximum of S minus K or 0, right? If you can recall. So based on that, you can say this 3 will be a negative value to you. So this will be minus 3 for you because you have a short position, not a long position. So now this will be the value of the portfolio if the stock price goes up. So what would be the value of the portfolio if it goes down then? If it goes down, so you have delta number of shares with you and the share price is 38. So number of shares multiplied by 38. But over here, now this would be, the payoff is 0. So this would be minus 0, or in other words, your value of the portfolio will be equal to delta 38, right? So if it goes up, your value of the portfolio is delta 42 minus 3. If it goes down, it would be delta 38. So we said we are creating a riskless portfolio. That means whether the stock price goes up or whether the stock price goes down, the value of the portfolio should be same. So with certainty, you would know what would be the value of the portfolio. So in other words, this cannot be different based on the stock price. So you can say that this, if it goes up, it is delta 42 minus 3. If it goes up, the value of the portfolio is delta 42 minus 3. So this should be equal to value of the portfolio if the stock price goes down. So that is, this should be equal to delta 38. So based on this, calculate and tell me the value of delta. How much do you get? So you can bring 3 to this side and you can say delta 42 minus delta 38. So you can take delta out and you can say 42 minus 38 will be equal to 3. Or in other words, delta will be equal to 3 divided by 4. So as you have already calculated, the value of the delta will be 0.75. So there's another way of getting this as well. So you have learned, right, this delta 0.75. So what this means is, then that means you have to learn 0.75 shares when you short one call option, right? To create a riskless portfolio. To create a riskless portfolio, you should long 0.75 shares when you short one call option. So here another way of in which that you can calculate this delta value is, you know that delta is also referred as the ratio between the option price and the stock prices, or the change in option price to change in stock prices. So you can take FU, or the call price when it goes up, minus the call price when it goes down, divided by the stock price if it goes up, minus the stock price if it goes down. So if it goes up, the option price is how much? The option price was 3. So 3 minus, if it goes down, the option price was 0. This value that we had over here. So 3 minus 0 divided by SU is 42. And our stock price, if it goes down, is 38. So this is also same as this. So this formula is in fact developed based on this argument where we create a riskless portfolio, right? So this will also be 3 divided by 4, which is 0.75. So either you can use this formula to calculate the value of delta, or you can use this argument where you equate the value of the portfolio at maturity. So now you know how much shares you will need when you short one call option. So calculate the values and tell me what would be the value then. What would be the value of the option at maturity? So consider this delta 42 minus 3, the value of the option. If it goes up, then how much would you get? Yes, so that is, now if you take this scenario where it goes up. So delta, we know if it goes up, the value would be delta 42 minus 3. So we know now delta is how much? 0.75. So you have 0.75 shares. That multiplied by 42, you will get the value of your shares, and minus the payoff of the option, minus 3. So this will give you how much? This will give you, calculate and see, you will get 28.5. So this will be 28.5. And then in this case, delta 38 will also be equal to what? Delta 38, if it goes down, the value of the option, that would be 0.75 multiplied by 38. then how much would you get? You would get the same value. So 0.75 into 38. So 28.5. Right? You will get the same answer. Respective of the stock price, you will have the same value in the portfolio, which is 28.5. So one of the students is asking how we assume whether we take a long position in shares and short position in option. So here, for you to use this formula over here, if you're using this formula, then you have to assume that you take the long position in shares and a short position in the option, right? Whether it's call or put, you take a short position in the option. So normally here, when you are developing the strategy, this can be either way. If you're using this approach, then you can change your strategy, right? Then you can change your strategy because if you're using this, because here we are making the value of the portfolio equal irrespective of the stock price. So here, but make sure if you're taking I have told this before as well, if you're taking a long position in shares, in call options, it should be the opposite position in call. So long position in shares and short position in call. Or if you're taking a short position in shares, it should be a long position in call. But if it is put option we are looking at, then if you are taking a long position in shares, you should also take a long position in put as well. If you're following this approach, then you don't have to worry. You can use whatever the strategy you want, but make sure that the position, if you're using put, the position should be the same in stock and the option, put option. And if it is put option you are using, if you are taking a short position in the stock, you should take a short position in put as well. Now I told you, so here when I'm using this formula, I will always take a long position in my shares and I will take a short position in my option, right? So in this case, if that is the case, what could happen to delta value? So now I said, so when I'm using this formula, I would always take a long position in shares, right? Long position in shares, and I would short position in option. So if I'm considering put option also, if I'm using this formula, I would take a short position in one put, right? I would take a short position in one put. So if that is the case, what can you tell about the value of the delta? The value of delta, will it be positive value or a negative value you would get over here? The value of delta. Delta wala value එක positive value එකක්ද negative value එකක්ද? It would be a negative value because why? You know, when you take a short position, you should definitely take a short position in shares. So you can write long over here, but in fact, your delta value will be negative, indicating a short position in shares. So you can, I will not actually do the second question. So second question is based on a put, but follow the same steps, right? Follow the same steps. Take a long position in shares. So adapt, stick to one strategy, then it is easier for you, right? Rather than complicating it for your convenience, stick to one strategy. So take the long position in shares and the short position in the option. So if it is a put, take a short position in one put and take a long position in shares. When you take a long position in shares, in case of put options, your delta value will be negative, indicating, in fact, implying a short position. Though you have written a long, this will give you a minus value. So let's first focus on this, right? So you saw now when you use 0.75, you get the same value at the end of maturity date, or at expiration, you will end up with the same value for your portfolio, which is 28.5. So now using this, so tell me what would be the value of the portfolio today? What would be the value of the portfolio today? So the portfolio today, you can write the value of the portfolio today as So so you can take the number of shares in which you took a long position multiplied by the number of shares multiplied by the share price minus the option price, right? Minus of the option price, because you have taken a short position. The payoff of the option today should be deducted minus the option price. So this will be the value of the option today. So this value of the option today should be equal to the present value of this value of the option at maturity, because we know for a riskless portfolio, if your portfolio is riskless, what is the return we said that you can earn? So if you want, you can simplify this, because we already know delta is 0.75. So you can take 0.75 multiplied by 40 minus F. So how much will you have then? So you can say 0.75 into 40, it is 30. 30 minus F will be the value of the portfolio today. And also you can derive the value of the portfolio today based on this 28.5 as well. Because we know this is a riskless portfolio that we have created. On the riskless portfolio, the return that you can expect is the risk-free rate of return when there are no arbitrage opportunities. So we are using the no arbitrage argument. When there are no arbitrage opportunities for a riskless portfolio, what you can expect is the risk-free rate of return. So get the present value of this and equate to this value. So that is, you can take 28.5, the present value of 28.5. So multiplied by E to the power minus R. R is 8% to the power minus 8% into the time. Time is, here we are looking at 1 month. So 1 over 12. So based on this, calculate and tell me what is the option price that you get. What is the value of the option? Solve this. Yes, so that is, you can say it would be, the value of the option would be 30 minus, if I take F to the other side, so I can say 30 minus 28.5 e to the power minus 8% into 1 over 12. So if you calculate this, you should get 1.689, right? 1.689, or you can say 1.9. You get 1.689 as the option price. So now that is based on the no arbitrage argument. And then what we can do is, next we can calculate this option price. This option price, the same option price, by using the risk neutral valuation as well, by using risk neutral valuation. So if you're using the risk neutral valuation, I told you what happens is, there you take the value of the option as the present value of the expected payoff of the option at maturity, right? Value of the option today will be the present value of the expected payoff of the option. Because why? On any security in a risk neutral world, the return will be the risk-free rate of return. So when you are calculating the present value, use the risk-free rate of interest. And to get the expected payoff, you need to find out what is the probability of a price increase and what is the probability of a price decrease. So can you, this risk neutral valuation is a normal way in which that you would find out the option price. So what you have been doing so far under the binomial option pricing model. So where you draw a binomial tree, identify the payoffs at maturity, take the expected payoff and take the present value of the expected payoff as at today. So try to do it on your own and see whether you get the same answer 1.689 as the option price. So here you will need to calculate the probability of the upward movement over here. So to calculate, that is denoted by P. P we calculated by taking e to the power RT minus D divided by U minus D. So what is the value of D over here? D is how much? What is the value of D you would get? So we say D is what? Yes, you can take D by taking, if the price goes down, what is the price divided by the price today? So that is 38 divided by 40. So how much would you get? Then 38 divided by 40, which would be 0.95. And the value of U would be, take the price if it goes up, which is 42, and divide it by 40, the price today. So this will give you 42 divided by 40, you will get 1.05. So what does this mean? So what is the percentage by which the stock price would go up and down? The stock price would go up and down by 5%. It would go down by 5% and it would go up by 5%. So yeah, D is 0.95, U is 1.05. So calculate and tell me the value of P. So here E to the power R is 8%. The value of T is 1 over 12 minus D. D is 0.95 divided by 1.05 minus 0.95. What is the value of P you get? P is the probability of a price increase. So calculate and see, as you have got you should get 0.5669. So that is the value of P. P is defined as what is the probability of the price going up. So what is the downward movement then? That would be 1 minus P. The probability of a downward movement would be 1 minus P, which is 1 minus 0.5669. So that would be 0.4331. So the probability of a downward movement. So now calculate and tell me what is the expected payoff. For we know if it goes up, the payoff is 3. The option will have a payoff of 3. If it goes down, if the price goes down, the payoff is 0. Then what would be the expected payoff? So we know if it goes up, the payoff is 3. But the probability of it going up is how much? 0.5669. So 0.5669. So though it is 3, the chance of it going up is this much. So this is what we can expect. Plus, if it goes down, it would be 0, and the chance of that happening is 0.4331. So if it is 0, you don't even need to consider that, because 0 multiplied by any number will be 0. So you can simply consider this part only, the first part. If you consider this part, that would be enough, because this value will be 0. So this will give you the expected payoff, right? The expected payoff of the option. But the value, we need the value of the option as at today. So to get the value of the option as at today, take the present value of this expected payoff, that is multiplied by E to the power minus RT, that is R is 8% multiplied by 1 over 12. This is 1 month that we are looking at, so multiplied by 1 over 12. So how much do you get? What is the value of the option, of this call option? Calculate and put the answers in the chat. So if you all have any questions, please ask and clarify, right? So in fact, if you calculate this, you should get the same answer that you got earlier, which is 1.689. Whether you use the no arbitrage argument or the risk neutral valuation, you should get the same answer. But if it is not specified as to what to be used, always go with this risk neutral valuation, because that is much more easier, right? Go with risk neutral valuation under binomial option pricing model. So here you would get 1.689. And for the next one, for question number 2, let's see. I will give you the answer for question number 2. You can attempt it on your own. So there you have. So if you look at question number 2, right? In question number 2, what you have is, you need to find out the price of the European put option. And this is only one step binomial tree that we are looking at, right? So, and you have to calculate the prices based on no arbitrage argument and the risk neutral valuation. So here, when you are developing the no arbitrage argument, you need to create a riskless portfolio. So take, like I told you, take a long position in shares. So for your convenience, use only this strategy, then it is easy for you, right? Take long position in shares and short the option. So short one put option. So when you do this, when you calculate delta, so we know now here when you're taking a long position, we say take a long position in delta number of shares. So this value of delta will be, actually it will be a negative value. The value of delta will, if you calculate it, you will get a negative value. So that's okay. Do the follow the same steps that we did previously. So you will be dealing with negative values over here, and you should get an answer of, for the second question, the answer should be, the option price would be 1.159, right? The answer should be 1.159, the put option price. So you can attempt it on your own. So you can use the risk neutral valuation as well. So when you use the risk neutral valuation also, you will get the same answer, 1.159, as the value of the option. So look at question number 3. So it says a stock price is currently 100. Today, the stock price is 100. Over the next 2 6-month periods, it is expected to go up by 10% or down by 10%. The risk-free interest rate is R is 8% per annum with continuous compounding. So first you need to calculate the value of a 1-year European call option where the strike price is 100. So K is 100. So draw the binomial tree first. So show the different parts that the stock price can take. So you start with 100. So the price of the stock today is 100. And we are looking at two steps here. So 6 months. And you will be looking at another 6 months later. 2 steps. So look at after 6 months, what would be the possible stock prices? Then after another 6 months, what would be the possible stock prices? So here you will have SU. What if it goes up? And here it will be SUU. If it goes up twice by the said amount, right? By 10% twice. And this is first it goes up and then it goes down. From here it goes down. Or you can have SD. SD is when it goes down. So after going down, it can go up. So this SUD and SDU will have the same values always, because irrespective of the order in which that you multiply, so here you are changing the order in which that you will multiply. So first, if you have 100, you will multiply, you will consider, now here your U is how much? The value of U would be 1 plus 1.1, right? And D would be 0.9. So another way in which that you can get this U is take 1 minus the percentage by which, so 1 plus the percentage by which the stock price will go up. So for D, take 1 minus the percentage by which the stock price will go down. So here it was 1 plus 10%, because the stock price is expected to go up by 10% and down by 10% as well. So 1 minus 10% will give you 0.9. So U will be 1.1, D will be 0.9. So whether you, here if you take XUD will be how much then? 100 multiplied by U first, which is 1.1, and multiplied by 0.9. And then if you look at SDU, it would be 100 multiplied by 0.9 multiplied by 1.1. So both of them will give you the same answer, because the order in which you multiply does not matter. So calculate the values of stock price over here and develop the binomial tree. So then this would be SDD. It will go down twice. So SU is how much? SU is 100 multiplied by 1.1. So here you will have 110. SD will be 100 multiplied by 0.9. You will have 90. And then SUU would be 110 multiplied by 1.1. Again, you will have 121. So here you can take again 110 multiplied by 0.9, which is 99. So even SDU will give you 99. And then SDD will be 90 multiplied by 0.9, which is 81. I hope you got these answers. So next, calculate and tell me what would be the value of the option at maturity under SUU. So what will be, I will consider this, since it's a call option, I will consider this as CUU. What would be the value of the option over here? What would be CUU? So how to get the payoff? So the value of the option will be the payoff at maturity. So that is, we know for a call option, it is the maximum of S minus K or 0. So here the K is 100. So the stock price is greater than the strike price. So your payoff will be 21. So here you will have CUU will be 21. So what is CDU or CUD? Either one. So over here, what would be the payoff? It is 0. Why? Your strike price is greater. So S minus K will give you a negative value. So it should be the maximum of S minus K or 0. So because of that, here you will have the payoff is 0. Over here, again, strike price is greater. So the value or the payoff will be 0. So for this call option. So now to get the expected values, we need to find out what is the probability of the upward movement and the probability of the downward movement. So take the probability of the upward movement. So you will have E to the power R. So here take delta T, right? Delta T is the duration of the time step. Delta T minus T divided by U minus T. So calculate and tell me what is the value of P. So E to the power R is 8%. Delta T is how much? So this option is for 1 year, but we are looking at a two-step binomial tree. So 6 months to 6 months, right? So here the duration of the time step is 6 months. So consider that 6 over 12 minus D, which is 0.9, divided by 1.1 minus 0.9. So calculate and get the values. So please do the calculations with me, so then it would be clear, right? So I will rounding it up, right? I will rounding it up. So I will write the probability of upward movement would be 0.7041. So then what would be the probability of the downward movement? Then it would be 1 minus P. If P is the probability of going up, then 1 minus P will be the probability of going down. So that would be 1 minus 0.7041, which is 0.2959. One minus P will be 0.2959, because you need these probabilities to calculate the expected values. So now let's look at what would be the value of the option at this point over here. What would be our CU? What would be the option price if it goes up once? Then what you need to do is you will need to take the expected payoff. So expected payoff is what? Take, if it goes up, the payoff is 21. The value of the payoff is 21. The value of the option is 21 if it goes up. But the probability of it going up is only 0.7041. So what you can expect out of this is only 0.7041. 0.041. Because why? This value over here will depend on these two values. And plus, if it goes down, what is the payoff multiplied by the probability of it going down? So here it would be 0, right? Here this would be 0. So you can ignore that part. And this will give you the expected payoff. And to get the value of CU, take the present value of this. So take the present value of this. That means this multiplied by e to the power minus 8% into 0.5, 6/12, right? Or you can take 6/12, or you can multiply it by 0.5. So how much do you get as the answer for CU? The call price, if it goes up once. So there you should get, if you calculate it correctly, you should get, I will take it for 2 decimal places and I will round it up and I would say it is 14.21. So you will have 14.21. So over here, what would be the value of CD? If it goes down once, what would be the value of the option? So here this will depend on two prices. So the expected value is whether it goes, if it goes up, the price is 0. If it goes down, the price is 0. From this point, if it goes up, it is 0. From this point, if it goes down, again 0. So that means the expected value will also be 0 as well. So here you can simply say it is 0. And then to calculate the value of the option today, you can consider these two values, because if it goes up, the value of the option will be 14.21. If it goes down, the value of the option is 0. So you can simply consider, if it goes up, you know, it would be 14.21. So that multiplied by the probability of this going up. The probability of this going up is how much? That is the p-value, 0.701. So 0.7041. 0.7041 is the probability of this happening. So if it goes up, you can expect 14.21, but the probability of that happening is only 0.7041. So this is the expected value. So plus 0 into, so in here, over here, it will be 0 anyway, right? 0 into 0.2959. So this is the expected payoff after 6 months. And to find the value today, get the present value of this. So that is this multiplied by e to the power minus 8 into 0.5. Calculate and get the answers. So you will get 9.61 as the answer over here, as the value of this call option. So the value of a 1-year European call option with a strike price of 100 will be equal to 9.61. So calculate what would be the value of a 1-year European put option with the same strike price. So here you can use the same p-values and this probability of upward movement and the probability of the downward movement. Because what? There is no change in the time step. There is no change in the rate of interest. And the probability of the price increasing is also 10% and going down is also 10%. So D and U will be 1.1 and 0.9. So you can use the same p-values and the same 1 minus p-values and calculate what would be the value of the option if it is a European put option, where the option is only exercised at maturity, right? So if that's the case, calculate and see. So one of the students is asking if the approach is not specified, that we can use either one. So I guess you're referring to the no arbitrage argument and the risk neutral valuation. So there what I would suggest is, so what you have looked at is only under no arbitrage, you have looked at only the one step model, right? So a one-step binomial tree with the one step, by using no arbitrage argument, how to derive the option price. So I would suggest go to the risk neutral valuation, because you have not looked at, if there are several steps, how to use the no arbitrage argument. So stick to the risk neutral valuation unless you are specifically asked to use the no arbitrage argument, right? Go with risk neutral valuation. But somehow, whether you use the risk neutral valuation or no arbitrage argument, you should end up with the same answer. So here you can have the same binomial tree. So with that, now we are looking at a European put option. So in the European put option, the payoff is what? The payoff will be the maximum of K minus S or 0 for a put. That would be the payoff. So in that case, now here, if it is 121, so the strike price is again 100. If it is 181, what would be the payoff? What would be the value of the option at this point? So if it is 121, the stock price is 121, the strike price is 100. So that means in the market, the price is higher, so you will not exercise this particular option. So here the payoff of the option will be 0, right? The payoff of the option will be 0. If it is 99, what would be the payoff of the option? The payoff of the option would be there. So K is 100, the stock price is 99. So 100 minus 99 will give you a positive value. So you can take 1 as the payoff of the option. And again, over here, this would be 100 minus 81. Because you have the right to sell it at 100. So you will exercise it and sell it at 100. So your payoff will be 90, which is strike price minus the stock price. Now, if these are the values, then calculate what would be the option price in these cases first, over the previous notes. So here, if you take, now I will take the put up price if it goes up once. If I take that into account, then I can write PU will be equal to, so first calculate the expected payoff. So we know if it goes up from here, if it goes up, the payoff is 0. So we can simply take it as 0. If it payoff is 0, the expected value will also be 0. Plus, if it goes down, the payoff is 1. But the chances of it going down is only 0.2959. So you will multiply this by 0.2959. So this is the expected payoff, but we need the expected payoff at this point in time. So you will have to find out the present value of this. So you can take e to the power minus 8% into 0.5. 0.5 because it is 6 months. We have to bring it back for 6 months multiplied by 0.5. So what is the value of PU? The put price if it goes up once. How much do you get? Yes, you would get. So I will keep it for 2 decimal places over here. The option prices I will take it is 0.28. So I will write 0.28 over here. So calculate and tell me what is PD then. If it goes down, yes. So if it goes down, then PD would be what? So if it goes up, it would be 1, the payoff. But what you can expect is only 0.2. Sorry, you can expect is 0.7041 out of this. And if it goes down from this point, it is 19. Out of 19, what you can expect is only 0.2959. So this will be the expected payoff at this point in time. So take the present value of that. So at this point, so to get the expected payoff at this point in time, take the present value of this, right? Minus to the power minus 8% into 0.5. So you should get 6.08. So here PD will be 6.08 if I round it up to 2 decimal places. 6.08. Then calculate what would be the put price today. Based on these values. So the value of P would be, so at this point the expected value will be, if it goes up, the price is 0.28, but the chances of it going up is only 0.7041. And if it goes down, the value is 6.08, but the chances of it going down is 0.2959. So this is an expected value that will happen, that you can expect after 6 months. So get the present value of that to find the value of the option today to the power minus 8% into 0.5. So calculate and tell me the answers. How much is the put price? So round it up to 2 decimal places. You should get 1.92. So that would be the put option price. If you round it up to 2 decimal places, you should get 1.92. 1.92. So check your answers. And then verify that the European call and European put prices satisfy the put call parity. So put call parity, we said, gives the relationship between the call option price and put option price with the same strike price and with the same expiration date, right? So options, European options that have the same strike price and the same expiration. So expiration date is also 1 year. The strike price is also 100. In that case, it gives the relationship between the option prices when both have the same strike price and same expiration date. So check and tell me whether these answers satisfy the put call parity. So we know for put option, the price was how much? We got 1.92. We said the option price should be 1.92. Previously, for the call option, how much did we get? For the call option, we got 9.61. Call option, it was 9.61. Put option price was 1.92. Call price was 9.61. So check and see whether they are appropriately priced now. Because we said that if it is not appropriately priced, that will lead to arbitrage opportunities. So see whether this is appropriately priced. So here, when we are taking the put call parity, what we say is, we say a portfolio with a call and an amount of cash equal to the present value of the strike price should be equal to the value of a portfolio with one put and a stop. So take first C plus the present value of the strike price. So C is how much? The call price that we calculated was 9.61. So we had 9.61 as C. Plus, take the present value of strike price. Strike price is 100. So 100 e to the power minus 8 into how much now? So here this won't be 0.5 because we are looking at the entire term of the option. The term of the option, which is 1 year, right? So we are looking at whether this 1 year call option is appropriately priced or not. So in deriving this value, we consider 2 steps. But 2 steps that will amount to 1 year, right? So take 1 year. So into 1. So how much do you get? You will get 101.92. 101.92. And then if you look at the other side, the right hand side of this put call parity, if you take P plus the stock price, it would be how much? P is, we got the value of the put is 1.92. And the stock price today was how much? The stock price today, it is 100. So take 100. So 100 plus 1.92 will also give you 101.92. So in fact, these prices satisfy the put call parity. So the answers are the same. So that means this European call and this European put with the same strike price and the same expiration date have been priced appropriately as specified by the put call parity. So this is the same. It satisfies the put call parity. So if you're done with that, can you move on to question number 4? So this question number 4 is actually where you have to, you have to calculate the price of an American option using this binomial option pricing model. And this is actually a past paper question, this question number 4. So can you attempt to do it? And in the meantime, if you do have questions with regard to what we did so far, you so read the question that is given to you. It says, suppose that the price behavior of an underlying stock follow a binomial distribution. Stock price today is S note is 300 and the standard deviation is 30, sigma value is 30, 1 times step. So the 1 times step is 3 months. The exercise price is 300 and the risk-free rate is 12%. So though it is not mentioned, assume that it is a continuously compounded rate of return. So risk-free rate is a continuously compounded rate, is 12%. So here you have been given the formula. So you have been given the formula to find U and to find D, right? Because for what purpose will you need D, U and D? To develop this binomial tree, you need to know what is the value of U and what is the value of D. So here it says the requirement is calculate the price of a 6 months American put option. So if it is the term of the option is 6 months. So if that's the case, your one time step is 3 months. How many steps will you have in this binomial tree? You will have 2 steps. So you start with 300. So price today is 300. But to identify the prices in the future at future points. So this can go up or down in 3 months. And again, that value can go up and down again in another 3 months. So to get the stock prices over here, we need to calculate what is U and what is D. So this formula where we identify this U based on the historical volatility of the stock price. So calculate and tell me how much do you get for U and how much do you get for D. First tell me how much do you get for U. So U is what? U is E to the power sigma or the standard deviation and the square root of delta t, the square root of delta t. So delta t is the duration of the time step, right? So when we denote it by capital T, we refer to the entire term. So when it's delta t, simple t, we refer to the duration of the time step. So if it is 1 step, then both of these will be the same, right? If it is 1 step. So based on this, what is the value of U? So E, sigma is 0.3, 30%. So 0.3 multiplied by the square root of, so we are looking at 3 months, the 3 months time step. So 3 over 12. So 3 over 12 is in fact 0.25, right? 3 over 12 is 0.25. So here 0.3 multiplied by the 0.3 into the square root of 3 over 12 will give you, how much is the value of u? So this should give you an answer of 1.1618. So here when you are taking, better if you can take these values at least for 4 decimal places to make sure the accuracy is there, right? For U, for D, for P, and 1 minus P, take at least 4 decimal places. And when you're calculating the option and the stock prices and the option values, you can keep it for 2 decimal places. But when you're taking these values, try to take 4 decimal places. Even if you do not take, that's okay, that's all right. But to increase the accuracy, we can consider 4 decimal places over here. And then D will be what? It will be 1 divided by U. So which is the easiest way. Or you can say, you can use this formula as well. Or you can simply take 1 divided by U. So what is the value of D that you would take? That you would get? 1 divided by the value of U, you will get how much? D will be 0.8607. Or you can say 0.861 if you round it up to 3 decimal places. So you can say 0.8607. So that value of D, and this is the value of U. So based on this, now identify, develop the binomial tree. Now identify what would be the stock prices in 3 months and then again after another 3 months. So this is would be what? 300 multiplied by U. So 300 multiplied by U is 1.1618. There you will get 348.54. That is 300 multiplied by 1.1618. And then again over here, this multiplied by 1.1618 again. So you will have 404.93. 404.93. And then if you look at this point, you can take 348.54 and multiply it by, now the price is going down. So multiplied by D, which is 0.8607. So here you can, you will get 299.99. So what you can do is you can round it up and say it is approximately, it is in fact 300. You can say, you can take the value of 300, that's all right. And then if it goes down over here at this point, it would be 300 multiplied by 0.8607. So here you will have 258.21. And again, if it goes down again, multiplied by D again, which is 0.8607, you will have 222.24. So I hope you got this binomial tree by using the values of U and D that you have calculated. So these will be the stock prices at these time points. So now we are actually looking at an American put option. So American options, you know that American options can be exercised early as well. So that can be exercised early at any point till the date of maturity. So for put options at maturity, look at what if it is exercised to maturity, look at what would be the payoff. Look at the payoff if exercised at maturity. Identify the payoff over here. So for put, Again, it would be what? It would be the maximum of strike price minus the stock price or 0. If it would be the maximum of strike price minus the stock price or 0. So here at this point, how much would you get as how much would you get as the payoff? At now here this would be SUU. At SUU, the payoff is 0. Why? Because K minus S will give you a negative value. You know that the value of the option cannot be negative. So the worst that it can be is 0. And here, again, the value of the option is 0. 300 minus 300 will give you 0. You can take it as 0. And in here, how much would be the value of the option? So take K minus S. 300 minus 222.24. So that is 77.76. So first, so once you identify this, calculate what would be the present value of these expected payoffs at these points in time. Right? What would be the present value of the expected payoff at these points in time at previous notes? So for that, to get the expected payoff again, you need to identify what? You need to identify the probability of the upward movement and the probability of the downward movement. So take P and calculate what is the value of P. So e to the power R into delta T minus D divided by U minus D. So how much would you get? E, R is 12%. So delta T is the duration of the time step is 3 months. So 3 months is in fact 0.25, right? 3 over 12, 0.25, 3 over 12. Minus D is 0.8607. 0.8607 and divided by U minus D, that is 1.1618 minus 0.8607 and get the answer for P. So you would get, as you have already calculated, you should get 0.5638 as the probability of an upward movement. So if this is the probability of the upward movement, calculate what is the probability of the downward movement, which is 1 minus P. So that is 0.1 minus 0.5638, which will give you 0.4362. So now using these probabilities, calculate the present value of the expected payoffs. So now what would be the present value of the expected payoff at this point? What is the expected payoff in 3 months or at this point? At this point, what would be the expected payoff? Expected payoff is 0. Why? Whether it goes up or down, the value of the option is 0. So the expected value over here is 0. So the present value of 0 will give you 0. So that would be 0. And then calculate at this point what is the present value of the expected payoff. So here, if it goes up, the expected value is 0 because why? If it goes up, the value of the option is 0. So this would be 0 plus, to get the expected value, if it goes down, there is a value of the option of 77.76. So which is the value of the option if it goes down. But the probability of going down is only 0.4362. the probability of going down is only 0.4362. So if you take that, so this will give you the expected value. So the present value of this, so get the present value of this to this point where you can multiply that value by e to the power minus 8%. Sorry, this is 12%. The risk-free rate of return is 12%. So take minus 12% into 0.25, which is 3 months. How much do you get the value over here? The calculated value, yes, the present value of the expected payoff would be, so the answers can be slightly different based on how you round it off, but you should get an answer closer to 32.92. So it should be 32.92. Now, here, since it is an American put option, you know, even at 3 months, you have the opportunity, you have the ability to exercise it after 3 months as well. So if you exercise it, so rather than waiting till maturity, if you exercise it at this point, at 3 months, tell me what would be the payoff. So you need to compare these calculated values with the intrinsic value at this point if you exercise it at this point. So again, you can use the same where we know the payoff is maximum of K minus S. So here how much is, if it goes up after 3 months and if you exercise at that point, what will be the payoff? Here the payoff will be, so K is, the value of K, the strike price is 300. 300 minus this value will give you a negative value. So that means the option will not be exercised. The payoff will be 0. But if you exercise at this point, the strike price is, so if you see the strike price is 300, the stock price is 258.21. So there is a positive payoff here. So you can calculate and see 300 minus 258.21. So that is 41.79. So what this means is that if you compare, so here rather you will be better off if you exercise at this point. If you exercise the option at this point, you will be better off. Why? Because you will get a payoff of 41.79. If you have waited till maturity, your payoff at this point would have been 32.92. So here you will select to exercise this particular option early if the price goes down after 3 months. So here when you are calculating the put price, when you are taking the expected value at this point, you consider here it is the same. Does not matter. You take the higher value. When you compare, take the higher value. So here it would be 0. So if it goes up, your payoff will be, the expected payoff is 0. If it goes down, the expected value would be, you take 41, because why? If it goes down, you will decide to exercise it. So you will take 41.79. But the probability of that occurring is 0.4362. 0.4362. So this will be your expected payoff after 3 months. So to get the value at this point, multiply this by e to the power minus 8%, sorry, e to the power minus the risk-free rate, which is 12%, into 0.25, which is 3 months. So then how much would be the value of this American put? you will get the value of American put would be, so this will be 0 plus 41.79 into 0.4362, right? So this will give you the expected payoff. Expected payoff, take the value of the expected payoff as at today. So that means discount this at this 12% rate for 3 months. So calculate again and see, you should get 17.69. You should get 17.69 as the answer. So check whether you get these answers based on these calculations. 17.69. So that would be answer for this particular question. So look at question number 5. If you are done with this, move on to question number 5. So question number 5 is based on the Black-Scholes model. So here it asks, so consider an option on a non-dividend paying stock. When the stock price is 30, the exercise price is, so here in this case, in this particular question, S note is 30. The exercise price is 29. K is 29. The risk-free interest rate is 5%. R is 5%. The volatility is 25% per annum. So volatility will be given as sigma, the standard deviation. 25% per annum. And the time to maturity is, T is 4 months. So it is 4/12 if you take it in years, 4/12. So now the requirement is they ask you to calculate what is the price of the option if it is a European cost. So here it is not actually specified whether to use the binomial or the Black-Scholes, because this was actually taken from the tutorial that was there for the Black-Scholes model. So using the Black-Scholes model, calculate and tell me what should be the price of the European core. So for you to calculate this, so these are the, I hope you can see this Excel sheet. So in here, so these are the equations that we use, the formulas that we use to calculate the call price and the put price under the Black-Scholes model. So to calculate the call price, and also you must have learned if you're using the Black-Scholes, what type of options can we do the pricing? For what type of option can we calculate the value, the price? Is it European? Can we calculate the price for both European and American both using Black-Scholes? So can we calculate the price of an American option and a European options using a Black-Scholes model? No, based on what you have learned, you should remember that the Black-Scholes model is used only for European options, European type of options. We cannot use to find out the value of American options. So here, if you take for a European option, we say the price of the European option under the Black-Scholes model should be equal to S note multiplied by the probability of B1. So to calculate B1 also, we have another formula. So this is the formula that we use to calculate B1. So if you want, you can take it down if you do not have the formulas with you right now. So this is the formula that we use to calculate B1. And then we deduct the present value of the strike price multiplied by the probability of D2. So this D1 and D2 will be Z values. So for those Z values, we need to take the probability values, or we need to take the probabilities of those Z values. So always, so the easiest way for you to remember is that this D1 will be associated with the stock price, will be associated with S note. This D2 will be associated with the strike price. So that's why when it comes to put options, right, we consider minus D2 and minus D1 when it comes to put option. But that's why when we take here under put options, we take the present value of the strike price and we multiply the probability of minus D2, because D2 is always associated with this strike price. So take minus D2 over here and minus S note into the probability of minus D1. So first here calculate, now for us to calculate the European call price, the requirement was what? In the tutorial, if you refer, the requirement is what is the price of the option if it is a European call. So under using the Black-Scholes model, what would be the price if you of this particular European call option? So to do that, we will have to use this particular equation here. We will have to use this. And in order to do that, so we have the stock price with us, we have the strike price given to us, we have the risk-free rate, we have the time to maturity, we have the value of T, but we need to calculate the probability of D1 and probability of D2. So to do that, first calculate what is the value of D1 using this particular formula. So what can you say? If you use that, so calculate and tell me the value of D1 that you get. So take ln. S note is how much? The stock price was given to us as 30, right? The stock price is given to us as 30. 30 divided by the strike price, exercise price was given to us as 29. So I will write the information that was given to us over here. So the stock price is 30. The exercise price was 29. The risk-free rate was given to us as 5%. The volatility, the sigma value, was given to us as 25%. And the time to maturity will be 4 months. So that is 4/12. So these are the information that were given to us. So take ln 30/29 plus R is 5%, the risk-free rate 5%, plus the variance or the squared value of sigma, you can take 0.25 squared divided by 2 and multiply this value by the time, 4/12, multiplied by 4/12. And divide this entire value by sigma into the square root of time. Sigma is 0.25 multiplied by the square root of time, which is 4/12. So how much is the D1, the value of D1 that you would get? So calculate and see, you should get, when you solve this, you should get this value. So you should get 0.4225. You should get 0.4225. Check the answers, right? So that will be D1. D1 will be 0.4225. Then the value of D2 will be how much? So to calculate D2, rather than using this, you can simply use this formula over here. It's a simplification of this. So you can say D2 will be equal to, now D1 we know, which is 0.4225 minus sigma into the square root of time. Sigma is 0.25, which is the standard deviation, into the square root of time, which is 4/12. And check and see how much do you get. So check whether you get this value over here. Check whether you get 0.2782 as the value of D2. The value of D2 should be 0.2782. So this should be 0.2782, right? D1 will be 0.4225. D2 will be 0.2782. So can you raise your hand if you got the answers for these? Okay. So the next step would be to find the probabilities of D1 and the probabilities of D2. So in order to find the probabilities of D1 and D2, so either you can use the calculator. So in here you can use the calculator. So here I've taken using the Excel, right? Excel function, I have taken the probabilities of D1 and D2. So if you're using the calculator, but most likely at the exam for you, you will be given the probabilities. If you're required to calculate this based on Black-Scholes, you will be given the probability values of D1 and D2, right? But you will have to, sometimes you could be given several probability values. So you should know what is the value of D1 and what is the value of D2, and then you should select the correct probability value. So if you take over here for D1, you will get a probability value of 0.6637. And for D2, you will get a probability value of 0.6096, right? So if you're using the calculator, one way in which that you can use the calculator is, in some calculators, first you will need to change the mode to stat, right? You will have to change the mode of the calculator to stat, and then press shift. So try and see whether it works in your calculator. This is not in old calculators, right? Not in the black color one, but in the new ones. Try and see. So you can change the mode into stat. So this is not actually needed, but I'm telling it for your knowledge. So change the mode into stat and press shift and number 1. And press or select the distribution, right? So in some calculators, the distribution can be in a different number. So change the mode, select mode, stat, and then press shift +1, and then there select distribution. So you will have something like this, distribution. So there are, in some cases, it will be the number 7, right? So select 7 and then select P, the probability values. You will have something like this. So where the number is 7 over here, in some calcs, you will have P will be given as 1. So you need to press 1 and then enter the Z value, enter the Z value, and then enter equals, you will get the probability value, right? So this is how you can get using the calculator. And but most likely at the exam, for you, if you are getting something like this, you will get the probability values. So now, if you use these probabilities that have been given to you, calculate and tell me what is the call price. So we know the call price, we can use this particular formula under Black-Scholes model. So C will be equal to S naught is, so the stock price is 30. 30 multiplied by the probability of D1. So take this value over here, right? Use these values that have been given to you. D1 will be 0.6637 minus, take the strike price, the present value of the strike price. The strike price was given to us as 29. So take the present value of 29 multiplied by E to the power R. R is 5%. So 5% into T. T is 4/12. T is 4/12. And multiplied by the probability of D2, which is point. Multiply this by 0.6096. 6096. So how much would you get? What is the value of the call option? So you will have, if you calculate it, you should get 2.52, right? You should get 2.52. So here, in fact, if you look at the exact answer will be around 2.53 based on the rounding off errors, because here we took only for 4 decimal places. We get 2.52, but that's all right, right? So then look at the next part of the question. So the next part is, so this answers the first part, part A, the price of the European call. The price of the European call is 2.52. What is the price of the option if it is an American call? So what can you say? The American call price? How much would it be using Black-Scholes? Any idea? So you learned that using Black-Scholes, you cannot find the value of American options. You can't find the value of American options. But now the exception to this over here is that here we are looking at an American call. So here we can derive the value for this American call based on the fact that you have learned that American call, is it optimal to exercise an American call early? So based on what you have learned, you should not exercise an American call early. It's never optimal to exercise an American call early. You learned 2 reasons for that, right? One is related to the time value of money. One is related to the insurance that you get. So because of that, you should always exercise even an American call. We say it is up. You should wait till the maturity. So then what can you say about the American call price? So even if you have an American call, if you're waiting till maturity, that is more like what? So that is more like a European call, right? So if an American call is not exercised early, and if you wait till maturity under an American call, then this is similar to an European call. So based on that, you can say the price of the American call should be equal to the European call price, which is 2.52 that we calculated earlier. So which is 2.52 that we calculated earlier. So next, look at part C. What is the European option price? The price of the European put. So this is the formula that we use to calculate the European put price. So here we already have D1 and we have already calculated D2. So previously to calculate the European call price, we calculated D1 and D2. So here instead of taking the positive values, we should take the negative values. So D1, you should take minus D1. So that is earlier you got D1 as 0.4225, right? Earlier D1, the value was 0.4225. So if you look at over here, the value was 0.4225. So here you should consider minus 0.4225 and D2 will be 0.2782. So you should consider minus 0.2782. And these are the probabilities for these values. Minus 0.4225, you get a probability of 0.3363. And for minus D2, you have a probability of 0.3904. So if that's the case, what is the value? So if this is the formula that you are using, use these values over here and calculate what is the European put price under these probabilities. So you know strike price is 29. So 29 into E to the power minus 5%, which is the risk-free rate. T is 4 months, so 4 over 12. So with the strike price, the associated value is D2. So take the probability of minus D2, which is 0.3904. So multiplied by 0.3904 and deduct this part over here, which is S note is 30. The stock price today is 30 and multiplied by the probability of minus D1, which is 0.3363. Calculate and get the answer for an European put. What would be the price under the Black-Scholes model? So if you round it up, you can say, if you round it up to 2 decimal places, you can say 1.05. So you should get 1.05 as the price of this European put option under the Black-Scholes model. Then look at the next part of the question. The next part, it asks you to verify that put call parity exists. So check whether the put call parity is there. So check and see. So it should be C plus. There can be slight differences based on rounding off, but there cannot be significant difference, right? So we say the call price plus the present value of the exercise price should be equal to put price plus S note. So if you take this one, how much do you get? The call price we got 2.52. The exact value that using Excel we had 2.53, right? But in our calculations we got 2.52 plus the strike price is 29 and take the present value of that to the power minus 5% into E to the power minus 5% into 4/12. So look at the value that you would get over here. So how much do you get on the left hand side? So based on these values, you will get 31.04. So now on the other hand side, if you take the value of P was, we took 1.05 and we took S note was 30. The stock price is 30. So you have 31.05. So this is actually, though the answers are slightly different, it's because of rounding off errors. Otherwise, this has to be equal, right? So if you took the exact value that we got using Excel, we would have got, now here in Excel, we got 2.53. So if it was 2.53, this would have then exactly been 31.05. So the slight difference is due to rounding off errors. Otherwise, the put call parity holds. So that should be your answer. And then look at part E. Approximate the value of a European call option considering the one-step and the two-step binomial tree. So if you use a binomial tree, right? If you use a binomial tree, so take one step and calculate the values. If it is one step, calculate how much would you get under the binomial or binomial option pricing model using a one step. So if you look at, so using a one step, right? So first you need to calculate what is U and what is D, because we know that the stock price today, is 30. But we want to identify what will be the part of the stock price in 4 months time. So we are considering one step. So the time step is 4 months. The time step would be 4 months. So this is after 4 months. So after 4 months, you will need to identify what will be the price of this particular stock. So in order to identify the price of this particular stock, you will need to find out what is the value of U and what is the value of D. So this U and D again, you can calculate based on what? Based on the historical volatility of the stock. So that is, you can use the previous formula that you use. That you can say U is equal to e to the power sigma into the square root of delta t. So here delta t and the capital T are the same because we are looking at one time step. So you calculate and see what is the value of U get, the value of U that you would get. So here you will have E, the sigma value was 25%. Sigma was 25, standard deviation was 25%. So take 0.25 and multiply it by the square root of delta t. Delta t is now, this is 4 months. So multiplied by the square root of 4/12. So this should give you, if you calculate, it should give you this 1.1553 value. So take e to the power 0.25 multiplied by the square root of 4/12. So that should give you 1.1553. So that is the value of U. So to get the value of D, what can we do? We can take 1 divided by U. Or you can say 1 divided by 1.1553. 1.1553. So if you do that, you will get the D value over here. The value of D would be 0.8656. 0.8656. If you divide 1 by U, you will get 0.8656 as the value of D. So based on that, you can do the calculation. Find out what would be the stock price. So that will be the next step. Develop the binomial tree. So if U is 1.1553, what would be the stock price in case of a price increase? If D is 0.8656, what would be the stock price if it is 25.97? So you should get these values over here. If it increases, 34.66. If it decreases, it should be 25.97. 34.66 and 25.97. So calculate and see whether you get these answers, right? So how I have got this is, so this is basically the stock price multiplied by U. And over here, it is the stock price multiplied by the value of D. And once you have identified the stock prices in 4 months' time in a one-step binomial tree, look at what would be the payoff of the options in 4 months' time. What would be the payoff of this particular option? So you know the payoff. So we are looking at the requirement was to find the value of a European call option considering 1 step and 2 steps. So we are looking at a European call option. For a call option, it is the maximum of S minus K or 0, right? So here, based on that, here S is 30 and the strike price is, sorry, S is 34.66. The strike price is, we had the strike price over here was 29, right? The strike price is 29. So based on that, here you will get the payoff as S minus K, that is 34.66 minus 29, which is 5.66. But in this case, S minus K, 25.97 minus 29 will give you a negative value. We know the price of the option or the value of the option cannot be negative. The worst that can happen is that it can be 0. So here it would be 0. So based on that, so this first identify, develop the binomial tree, then identify what would be the payoff at maturity, what would be the payoff in this case in 4 months' time. And then we need to find out the value of the option today would be the present value of these expected payoffs. So these are the payoffs if it goes up and if it goes down. So we need to find out the probability of it going up and the probability of it going down. So P will be e to the power R into delta T minus D divided by U minus D. So P is e to the power R. R is 5%. So you can take 5% into delta T. Delta T is, here we are looking at 4 months. So 4 over 12 minus D. D you calculated as 0.8656. So if you are done with this, develop the 2-step as well, right? While I'm doing this. So divided by U minus D. U is 1.1553 minus 0.8656. Right? So here, if you, based on this, if you do the calculation, check whether what is the answer that you would get for P. So the value of P, you can take, so in here based on Excel, you have got a different value. But here, if you do this calculation, you should get 0.5219, right? So you should get 0.5219 as P. And 1 minus p would be then how much? 1 minus p would be 1 minus 0.5219. You will have 0.4781. So the difference from here to this, if you compare these two, the difference is due to rounding off errors, right? 0.4781. So using these probabilities, using 0.52919 and 0.4781, you can calculate what is the expected payoff and then take the present value of that expected payoff. So that is, you can take, now if it goes up, the payoff is 5.66. But the probability of it going up is only 0.5219. If it goes down, there is no payoff. So the expected value, if it goes down, will be anyway 0. So this will give you the expected payoff at maturity. Take the present value of that, e to the power minus, now the risk-free rate is 5%, to the power minus 5% into 4/12. So you should get this, you over here you will get 2.91. But if you do this, if I round it up, I will have 2.91. But if you do the exact values, should be, the exact answer should be 2.9. So that would be the value of the call if you use a one-step binomial tree. If you use a one-step binomial tree. So can you raise your hand if you got these answers for this one step? If you got 2.9. Okay. So that would be based on one step. And then if you look at the two-step, you should have got these answers for the two-step binomial tree. So if you consider two-step, so in two steps, so the entire time period is 4. So if you're considering two-step, that means one step would be for how many months? One step would be for 2 months. So you will have 2 months. That will amount to 4 months, right? 2 months will be there. That will lead to 4 months. So this is in fact, the time step is 2/12. So if you look at over here, it is 2/12. So that is the duration of the time step. And again, similarly, you will have to recalculate u over here in the way that you did before. Because why? The time step is different. So the value of u will be e to the power sigma into the square root of delta t. So e to the power sigma was 0.25, 25%, multiplied by the square root of, you can take 2/12, right? Take 2/12. So you should get 1.1075 if you round it up to 4 decimal places. And to get the value of d, you can take 1/u to get the value of d. So to get the value of d, you can take 1/u. So that is 1 divided by u, 1 divided by 1.075. So the value of d, you should get 0.9029 based on this, right? Based on this, in this manner, you should get 0.9029. The exact answer would be around 0.9030. So there's a slight difference based on rounding off errors. And then So once you identify this, once you identify U and D, you can develop your binomial tree. You can develop the binomial tree. So you will start with 30. So this binomial tree, first it will go up and down in first 2 months, and again in the next 2 months it will go up and down. So there will be 2 steps in your binomial tree. So this is the first 2 months period, and this will be the second 2 months period. And these will be the option prices that the stock prices that you will have. So 30 is the price today. 30 multiplied by you will end up. So the answers can be slightly different on what you used, right? So you should get 33.22 or an answer which is very close to this. 30 into u, 30 multiplied by u. And again, this multiplied by u again. This multiplied by u again, you will get 36.79. And this 33.22, if you expect a decline, then 33.22 multiplied by D, which is 0.903. So you will have 30 as the stock price. And again, over here to get 24.46 multiply. So this value will be 30 multiplied by D. And over here it will be 27.09 multiplied by D again. Or in fact it is S naught multiplied by D twice. S naught multiplied by D twice. So these will be your stock prices. These will be the value of the parts that the stock price will take in this 2-step binomial tree. And again, so this is a call option that we are looking at. In a call option, the value is the maximum of, the payoff will be the maximum of S minus K or 0. So based on that, identify the payoff of the option at maturity. Based on this, identify the payoff at maturity. So at maturity, now the strike price is how much? The strike price is 29. So did you all develop this binomial tree? The 2-step binomial tree, have you all already developed that? Can you raise your hand? If you all have formed the binomial tree, the 2-step binomial tree. So if you all need more time, you can request in the chat. Or if not, if you move forward. So you have the strike price is 29. So this is the stock price now. So the stock price minus the strike price, you will have a positive value. So that will be the payoff. That is 36.79 minus 29. So 36.79 minus 29 will give you 7.79. So that is the payoff at that point in time if the stock price keeps on moving up. And then over here, if the stock price is 30, again you will have a positive payoff. That is 30 minus 29 will give you 1. So your payoff will be 1. But if it is 24.46, what happens? Your payoff, if you take S minus K, S is 24.46, K is 29. So 24.46 minus 29 will lead to a negative value. So again, the payoff cannot be negative. The worst that can happen is 0. So the worst that can, since the worst that can happen is 0, the worst that can happen is that the option expires worthless. The payoff is 0 in this case. So once you identify the payoffs at maturity, next, since you have to move back towards this side, you need the probabilities of upward movement and the probabilities of downward movement to find out the expected payoff values. So for that, you have to calculate what is the value of P and what is the value of 1 minus P. So if you take P, again, you will have to recalculate why the time duration is different. The duration of the time step is different now. So P is e to the power r into delta t minus d divided by u minus d. So r is, in this case, was given to us as 5% into delta t. So delta t is 2 over 12 because it is 2 months. Now the time step is 2 months minus d. So you can take this one as well, the one that we calculated, which is 0.9029, and divide by u, which is 1.1075 minus 0.9029. So based on this, if you use this, you will get 0.5155 if you round it up to 4 decimal places, but the exact answer will be 0.5154 using Excel, right? You would get the exact answer as 0.5154, but if you use, due to rounding off errors, you will have 0.5155. So if this is the case, 1 minus P would be then 1 minus 0.5155, which would be 0.4846. Either you can use this or you can use these exact values. That's okay. So calculate and see whether the expected payoffs that you get is equal this answer 2.53. Whether you get this 2.53 when you calculate it backwards. First get the expected value using the probabilities, then get the present value of the expected value. Again over here, get the expected value and take the present value of the expected value. And check whether you get answers that are closer to this. So if you got 2.53, can you raise your hand? Or even if you is 2.53 answer, or an answer that is very close to that. So calculate and see. So it's okay. Sometimes you might get at least to 1 decimal places. It should be equal, at least to 1 decimal place. For 2 decimal places, it can be slight because one of the students have got 2.49. So that's okay, because if you take it for 1 decimal place, it would be 2.5. So it should be something that is even this also, if you take for 1 decimal place, it will be 2.5. So it should be an answer that is closer to this. But somehow make sure that you follow the correct steps in arriving at this particular answer. And also make sure that you show the steps as well, right? At least write the steps, because sometimes then the examiner would know that you have correctly approached the question, right? Rather than straight away put in the answers like this, show the steps that you have used in your calculations. So that would be the answer that you would get if you use 2-step binomial tree. And if you use 3-step binomial tree, the answers. So you can try it on your own, right? You will get 2.62. Under 3-step, it is not, so over here, the months won't be exactly divided. But if you take 4 steps, then the duration of 1 step is how much? In a 4-step, the duration of 1 step, if it's a 4-step binomial tree, how much would be the duration of 1 step? So altogether, this is 4 months. So if you have 4 steps for the 4-month period, 1 step would amount for 1 month. So that is your T would be 1/12. Yes, the duration would be, the duration of 1 step is 1 month. So the value of delta T. So value of delta T will be 1/12. So there, if you use that, you will get 2.56. So if you use this, compare these answers, under 1 step, you will get an answer of 905. 2 step, if I take it for 3 decimal places, 2 step, I get 2.528. And 3 step, again, a higher value. So you learned at the lecture for odd numbers in the steps, you get a higher value. And for even numbers, you get a lower value. So as you can see, 1, you get a higher value of 2.905. 2 step, you get 2.528, which is a lower value. Again, for 3 step, you have a higher value, which is 2.624. Again, for 4 step, if you see, you will end up with 2.56. So ultimately, this will go towards this the coal price that you got under the Black-Scholes model, because we say under Black-Scholes model, the accuracy is high. But when you increase the number of steps, this will move towards this the price of Black-Scholes model, but in a zigzag pattern, right? It will go in a zigzag pattern, but it will move towards that, but it will never be this exact price. It will move towards that, but it will never be that exact price. So we say Black-Scholes models, even though the accuracy is high, the applicability is less, because we can use it for only for European options. But binomial, the application, it's more useful, because why? We can use it for both European and for American options as well. So that's the end of the tutorial, and I will stop from here and attempt that question number 2 that I did not do, and I gave you the answer, so try and see whether you can get that particular answer. And if you do have any questions, you can contact us and clarify your doubts. And so I will stop from here. Thank you very much for joining in.